Problem 4. The continuous function f is defined in the interval -4 to 3. The graph of f consists of two quarter circles and one line segment, as shown in the figure above. Let g of x equal 2x plus the integral from 0 to x of f. Part A. Find g of -3, find g prime of x, and find g prime of -3. All right, to find g of -3, basically I'm just going to go into that formula. Wherever I see an x, I'll put a -3, so I'll have 2 times -3 plus the integral from 0 to 3 of f. Actually, it was from -3. I'm going to simplify this a little bit more. 2 times -3 is -6. And then I'm not allowed to go from 0 to -3, so I'm going to have to take the opposite of when I go -3 to 0 of f. And then I'm going to have -6 minus, to get the area under the curve from -3 to 0, I do notice that this is one of the quarter circles. So I'm going to have 1/4 pi times the radius squared, so it's going to be times 3 squared. So this will give me -6 minus 9/4 pi. And that was it. That was worth 1 point. The next one they asked me to find is g prime of x. To get g prime of x, I'm basically just going to take the derivative of g of x. So I'll take the derivative of each part. The derivative of 2x is 2. And then the derivative of the next part, if it's asking me to take the derivative of an integral, the derivative and the integral cancel each other out, and I'm left with f, but I will put f of x because my variable is going to change to an x. All right, so that's worth 1 point. And then g prime of -3, is that what it asked for? Yep. We'll just plug in -3 wherever we see an x, so we'll put 2 plus f of -3. So it will be 2 plus, to get f of -3, this is f, so I just look up -3, and that gives me 0. So 2 plus 0 is 2. So that answer was also worth 1 point. Okay, part B. Determine the x-coordinate of the point at which g has an absolute maximum on the interval -4 to 3 and justify your answer. Okay, absolute maximums, we always find the critical number and then we test the critical number and the endpoints into the original function. So the first thing that I need to do is get the critical point. To do that, I'll set g prime equal to 0. So I'll take 2 plus f of x and set it equal to 0. When I do that, I'm going to subtract 2 from both sides. So I'm going to get f of x is equal to -2. So I want to know, where does this function f equal -2? Where is the y value equal -2? So notice here's my y value of -2. I'm just going to follow it over here. It's going to happen at that point right there. And I believe that x value is 2.5. So x equals 2.5. That's my critical number. So 3 things that I need to do, and I think I'm actually going to go up here to do them. I need to find g of 2.5. Then I'm going to find g of the endpoint, g of -4, and then lastly, I'm going to find, I think I'm going to do it over here actually, I need to find g of 3. Okay, to find g of 2.5, just like we did in part A to find g of -3, it's going to be 2 times the x value plus the area under the curve from 0 to 2.5 of f. All right, so to get this, 2 times 2.5 is 5, plus, to get the area from 0 to 2.5, I actually have 2 triangles that I'm going to be working on. This first triangle is 1/2 times the base, which will be 3/2, times the height, which will be 3, and then I'm going to subtract, because this next triangle is underneath the x-axis, 1/2. 1.5 to 2.5 will be 1, times, at 2.5, that y value is 2. So when I do that, I'm going to get 5 plus 9/4 minus 1. 9/4 minus 1, this is like 2 1/4, minus 1 is going to be 1 1/4, so 5 plus 1 1/4 will be 6.25. Okay, so that's g of 2.5. Okay, to get g of -4, it's going to be 2 times -4 plus the area under the curve from 0 to -4 of f. Just like we did in the last one, we're not allowed to do that, so I'm going to get -8 minus the integral from -4 to 0. And then that's going to give me -8 minus, from -4 to 0, first of all, to get from -4 to -3, that is a quarter circle, so it's going to be 1/4 pi, and the radius of that circle is just 1. And then, and that's going to be negative because it's underneath the x-axis, whoops. And then plus, we already found this area to be 6 plus 9/4 pi. We don't need to do the negative quite yet, excuse me, because we have the negative sitting out front. Okay, so we're going to get -8. Let's see what we've got going on here. Here I have negative pi over 4 or negative 1/4 pi, plus 9/4 pi. That's going to give me 8/4 pi, which is 2 pi. So it's going to give me minus 2 pi plus 6. So I'm going to get negative 8 minus 2 pi minus 6, which will give me negative 14 minus 2 pi, I believe. The biggest thing I know about that one is a negative answer, and for sure that's not going to be the absolute maximum. Okay, hopefully I didn't mess up somewhere in my work there. All right, g of 3 now is going to be 2 times 3 plus the integral from 0 to 3 of f. 2 times 3 is 6, and then the area under the curve from 0 to 3, I notice there are two triangles that are going to cancel each other out, so it will be plus 0. So this will be 6. So I see that at 2.5, I will get my maximum value. So it says determine the x-coordinate of the point at which g has an absolute maximum. So absolute maximum at x equals 2.5. And I did justify my answer because they were easily able to see, hopefully you were easily able to see that I found the g values at all the endpoints and the critical points. Okay, that was worth 3 points. If you consider g prime equaling 0, so if you at some point in time set the derivative equal to 0, give yourself a point. If you got your answer of 2.5, give yourself a point. And then if you justified your answer in some way, give yourself that third point. All right, part C. Find all values of x on the interval -4 to 3 for which the graph of g has a point of inflection. Give a reason for your answer. Okay, points of inflection force me to look at g double prime. If you recall that g was the area under the curve, which makes g prime the curve, which makes g double prime the slopes of the curve. So we're going to be looking at the slopes of the curve. So if I make a g double prime chart and I'm looking at the slopes of the curve, the slopes are positive because the graph is going up till I get to 0, and then negative after that. That's all there is to it. So there is one point of inflection. The point of inflection is at at x equals 0, and it said give a reason for your answer, so I will say because g double prime changes sign, and that's all I need to do for that one. All right, we might somewhere here just in case. G double prime was actually f prime. G prime was actually f, and there we go. All right, that was worth just 1 point. Okay, part D. Find the average rate of change of f on the interval -4 to 3. There is no point C for which the derivative f prime of c is equal to the average rate of change. Explain why this statement does not contradict the mean value theorem. Okay, average rate of change is just a slope. So for part D, I'm going to do y2 minus y1 over x2 minus x1. If these are my endpoints, I notice that the 2 points that I'm going to be dealing with are -4, -1, and 3, -3. So I'm going to get -3 minus -1 over 3 minus -4. That's going to give me -2 over 7. So it asked me to find the average rate of change. I did. That was worth a point. And then it says to explain why this does not contradict the mean value theorem. So if you recall, the mean value theorem states at some point in time the derivative is equal to the slope, and the two conditions for that need to be met: number 1, the function has to be continuous, and number 2, the function has to be differentiable. Okay, you'll notice this function is definitely continuous because there's no holes or gaps or jumps or anything. And then differentiable means you can take the derivative of it at every single point. Well, I noticed that at x equals 0, we can't take the derivative because there's a sharp turn. So I would say the statement does not contradict the mean value theorem because at x equals 0, f is not differentiable. So, and that was worth 1 point.